Hey, it's Mr. Allred, and we're here. We're going to talk about factoring, which is a pretty big topic. We've already talked about prime factorization, where we've broken numbers down into common factors. But factoring is kind of separating a statement into things that produce a product, and we call that their factors. We can think of it as reversing the distributive property as I have here. So usually factoring means you're creating a product instead of sums. So it's the reverse of the distributive property. So here's the example I've got. If we talked about the distributive property of 6x times the quantity of 4x minus 3, we would get 24x squared minus 18x. And because that's what we got, when we go to look at factoring, we see that 24x squared minus 18x has a common factor. That means there's something in both these terms, the 24x squared and the 18x, that they're both divisible by. And that would be the 6x. So we could kind of pull that out and divide the rest of the terms by the 6x and get back through the distributive property. Okay. So let's do a couple quick examples there, and then we'll look at some variations in other videos. So here we are, we're going to factor out, or we're going to pull out a common factor. So and these will be pretty simple because we're looking for a term to come out of each term, which may not always happen, but the examples I have here it will. So we have 2x squared plus 4x. So we need to look at both of those things, 2x squared and 4x. And we're trying to see if they have any factors in common, which first thing we would look at is to see if they have any numbers in common. So 2 and 4 are both divisible by 2. So I'm going to pull this out and I'm going to put a parentheses over here and kind of do it in baby steps. And if I divide 2 by 2 would be 1, which I generally don't write, but I like to make sure we're staying with things here. And if I divide 4 by 2, I will get 2. So if I push this 2 back in the parentheses, it would give me 2 for the 2 in front of the x squared and 4 for the 4 in the second term. And then I look at the x squared and the x and realize they're both divisible by x. And if I'm looking at exponents, I'm looking for the lowest power. So if I pull an x out of x squared, it's kind of like I'm putting one over the other and dividing it. So that would leave me a single x, and the other one would be x over x, so there wouldn't be an x term. So that thing breaks down into 2x times x plus 2. Okay. The next term I have here, 6xy plus 18x minus 12y. Okay. So 3 terms, and if we're going to pull anything out of the whole statement, it needs to come out of all 3 terms. So one thing I look is I see in the numbers I have 6, 18, and negative 12. All 3 of those are divisible by 6. I'm going to leave myself a little room just in case. Divide 6 by 6, I get 1. If I divide 18 by 6, I get 3. And if I divide negative 12 by 6, I get negative 2. Okay, and then I look at the other ones. The first 2 terms have an x, but the last one does not. So there's no x in common, so I can't pull any of those out, so I'll just keep them where they are. The first and last term have a y, but the middle one does not. So I'll leave those where they are. So I can only pull out a 6, and that would be left being times the quantity of xy plus 3x minus 2y. Okay. My last example down here has 2 terms, 7xy squared plus 14x squared y. So I'm looking for anything to have in common. So I'll start with the numbers. 7 and 14 are both divisible by 7. It may not be so obvious in other questions, but if I divide 7 by 7, I get 1. If I divide 14 by 7, I get 2. And then there's an x in the first one, x squared in the second one. I can only pull out what they have in common, and they both share a single x. So pull it out of the first one, no x's are left. Pull it out of the x squared, there is an x left. The y's, I have a y squared and a y, so there's at least one y in both. Pull it out of the first, there's a single y left, but none in the last. So the factoring here gives me the two products of 7xy times the quantity of y plus 2x. And if you're ever worried about whether or not your distributive property worked, or excuse me, if your factoring worked, you can go back and check it with the distributive property. You could get rid of these parentheses by pushing that 7xy back in, and if you did it correctly, you should get the original statements you had. Now that's the opposite of factoring, but it is a way to check yourself. All right, thank you.